So hello everyone, and my name is Yongchao. I'm right now a final year PhD student in Harvard and MIT, working on like foundation models, post training, this kind of stuff. And this work Tumix is done when I'm doing the research internship in Google DeepMind. And so the title is multi-agent test time scaling with two-use mixture. And first, let me show you why I want to do this project. And you can see in this figure. And I remember about like the 1 year ago, these two questions are very famous to test the SOTA models, or even for right now, the leading models. People ask like 9.11 and 9.9, which is bigger. And then you'll see the LM will answer wrongly. And another question is like how many R's in this word strawberry and the positions. You'll also see the LM will answer wrongly. However, when I look into these two questions at that time, I have one like thought. So for these two questions, if we just add another prompt here, like use code to answer the following question, then LM will like answer correctly. Because in this case, you can see the LM will generate the code to answer the question, and that will be much easier. But then another thought comes into me, like there is one bottleneck. I mean, how can LMs choose between code and text without hints? I mean, for many like input questions, people always don't have this kind of like the predefined like hints, like whether you need to use code or not, or just use text to answer this question. And if we look into the current like leading models like Gemini 2.5 Pro or Grok 4 or ChatGPT agent, in their technical report, they always say that they use this kind of like the code interpreter or like web browsing, these two tools to help LM reasoning capabilities. And they always report like, okay, so when we use like the browsing and when we use the computer terminal, like the code interpreter, the performance will be much better. But when we look into the technical report, the details, we'll find there is no like clear like description like how they use these tools, like how they enable the models to like extensively utilize the capabilities of these two tools. So now it comes into my work just like 1 year ago, like at that time I just test are the current methods they are smart enough to switch between code generation and text reasoning. And I test on ChatGPT all the models at that time, and I find the answer is no. So so in our field we at that time we just study many different aspects of like the limitations for like the ChatGPT code interpreter. And here is one typical limitation. So when we just like ask the ChatGPT like what's the result of like the 2-digit number multiplying 2-digit number, we'll see the answer is correct. In this case, it will generate a test, and then the test is correct. And one is very, very complex, like many digit number versus many digit number is also correct because in this case, you can see the blue tag here. And the blue tag shows it generates the code, and then the result it comes from the code execution. However, the problem appears if one like it's a medium hard one. When it's like 4-digit versus 4-digit, the LM will generate the test as the answer, and then this answer is wrong. So in this case, LM is overconfident. And even for now, like the best model, like GPT-5, we still find these kind of problems. For example, we just ask the LM to solve this equation, and then the LM will directly use textual reasoning, and then the answer is wrong. And we ask it to like further do the prompting and ask it to solve this question with code generation. And you'll see still yeah, truly it generates code, and then the result from the code is correct. But actually, it will still use textual reasoning to answer, and that is wrong. And then in the third time, I just show like no textual reasoning here, and then you'll see you generate the code, and then it's correct. So this kind of like the alignment issue still exists. Like the kind of model they can't extensively utilize like the tool use capabilities very well. And then I think about like that. Are there like any training free methods that can handling task diversity? And what I think is like in our like Tumix work, what we do is like we try to handling different tasks by like agent diversity. I mean, and then we pre-design many different agent or many different like strategies to utilize the tools, and then we do the test time scaling, like a mixture of strategies to better utilize all the capabilities of each strategy. And here is our performance. You'll see in the very typical benchmark like HLE, humanities last exam, our Tumix framework can lift the Gemini 2.5 Pro's performance from 21.6 to about 34, and also on GPQA or on AMI. And so here comes into our framework. The framework is very straightforward. We pre-design many different tool strategies. One agent is just use pure textual learning, and another is always generate the code as the answer. Another is always do the web browsing. And other agents it's kind of the combination of all these kind of methods, or just a multi-term. And then when the question comes in, each agent will generate its own reasoning capability and also the final answer. And then we concatenate all the reasoning capabilities, all the reasoning and the answer trails together, and then feed it back to each agent. And then each agent, and ask each agent to generate the answer again, refine their answer. And so you can see during this kind of round by round refinement, the accuracy will ascend. So that's the whole process. And this guideline you'll see is inspired by humans. For humans, we always have this kind of group of the experts in one room, and then they will discuss all the different solutions, brainstorm different solutions, and then try to select the best answer from these solutions. And so here are all the 15 different agents. Some of them integrate the search and the code interpreter tools, some not. And you can see here is the typical evolutionary curve. The orange line here is the average accuracy or average score within this group, and in each step, in each round. And you will see when this kind of round by round refinement goes on, the agent accuracy will ascend very rapidly. And the blue line here is coverage. Here coverage means it's kind of like the best of n. Among these agents, if there is one agent that's correct, then we regard it as correct. So it can be regarded as the upper bound for within this group. And you'll see the accuracy the coverage will decrease. That means the diversity among these agent answers, they are decreasing. Because these kind the answers, they are shared among the agents. So during this kind of round by round refinement, the agent answers, they will attempt to converge into one or two answers. And so here you can see is the Sankey diagram. Here we just characterize for each round, for each question, how many agents they answer correctly. So 0 means 0 agent answer correctly, and 15 means all agents are answered correctly. And you can see by this kind of round by round refinement, especially from round 1 to round 2, the zero question, the questions that are answered 0 correct, they will decrease. You can see their portion will decrease. And what that means is that after this kind of first round exchange of their answers, there are some questions that initially all the agents they can't solve, and then in the second round, after they exchange the answers, some agents they can truly solve for this kind of 0 correct answers. So that means the sharing stimulates the LM potentials. And also you can see when the refinement goes on, the all correct one, their portion, and all wrong one, their portion, they will increase. So that's reasonable, because in this case it means the LM answers within the same group, they'll converge into one answer, and that one answer tend to be correct or wrong. Yeah. And another takeaway is that we found agent diversity and quality are very important, especially for diversity. Here we compare like 15 different agents versus 3 agents, but each agent influence 5 times on the different temperatures versus 1 agent and influence 15 times. And we compare when we compare, we will find the 15 different agents will be better than the 3 agents and the 1 agent settings. So because these 15 different agents, they are more diverse. Yeah. And this kind of diversity will increase your the potential. And another is we find the tool use enhances the performance. So we compare the agent groups. These agent groups has both code and search tools versus only code versus only search. And you'll see the performance is also better because I think it's kind of like the extra tools. They enhance the both the diversity and the quality. And another how do we terminate this refinement? I mean, in which round for each question? How can we determine when do we finalize the answer? And here the way we do is that we just ask LM to determine whether to finalize answer. But here we still set a minimum round of 2, because we find sometimes LM will early terminate. And also we find one different selection methods. They will finally result in 2 close performance, because in the later rounds, the group of agents, their answers are very converged. So in this case, which selection method, that doesn't matter. And so here is the scaling curves, scaling curves for the agents, and also scaling curves for the influence numbers, and the scaling curves for the token numbers. And so you'll see the agent types, the agent diversity will saturate around 15, because in this case around after 15, if we further increase the agent types, you'll see there is no benefit here. And then we suspect that's because with more agents, it's also hard to select the correct answer among these agent answers. And another is the scaling law, and you'll see for our methods, it will scale more rapidly and saturate into a higher upper bound than other methods. And here is another direction, the further work, how do we make this framework better? And one direction is we can design better agent groups. And so here we query the LM, the Gemini 2.5 Pro itself, to generate better and more diverse agents based on the current ones. I mean, we input the code for each agent and ask LM to directly generate the complete code for other different agents. And here we also calculate for the among these agent groups, what's their coverage and average score. And you'll see, compare with our baseline, this triangle here, there are many agent groups that can be better. So, and you can see when testing, they will slightly increase the performance. And here, and another direction, I'm not showing here, but we recently found is that we can use different LM types. So here in our work, we just use one LM with different agent types. Another way is the agent types are different, and also the LM types are different. And we tested, we found if they are the 2 LMs, their performance are close, and then we ask them to generate, even they just generate the same agent and generate answer, they will still fall into a stronger group than just use one LM's group. Yeah, so that's another direction. And yeah, so that's all about my presentation today.
Awesome. Thank you. Thank you so much. I actually have a question. So, you mentioned that one of your future directions was to, test this process out with different LLMs. I know it's a future direction, but do you have any kind of prediction in what kind of agent groups would be best, for other LLMs, or is it just too hard to say for now?
Oh yeah, great question. So we actually truly get some initial results, and we find these initial results are very promising. And what you find and we test we test Q1 3 32 billion model, And also we test GPT OSS 420 billion model. And we found these two models, their performance are very close, but there are different types of LMs. And then we ask them to form a group, like each agent, each LM just like form like 7 or 8 agents. And then they gather into one group, and then they use Tumix framework again. And we found in this case, this kind of like combined group, they will perform apparently better than like each LM from one group. And they are on the same LM, same number of agents and also same agent types. And we found that's because they are this kind of agent group, they are more diverse.
Got it.
Yeah.
Okay. It looks like we have one audience question, and it goes, I don't think I fully understand the blue coverage curves on slide number 17. What is the connection between accuracy on the y-axis and coverage?
Oh, great question. So yeah. So here, accuracy means like the average, just like the average score, the average accuracy among all the agents in the same group. And the coverage means like in these agent groups, for this question, if there is one agent answers correctly, then we regard it as correct. So you'll see is we can regard as this blue curve. The coverage means the upper bound for these agent groups. Yeah. And you'll see when the refinement goes on, this coverage will decrease. So that means because the answer diversity are decreasing among this kind of round by round refinement, and so in this case, their coverage will decrease. And I think a better method is kind of like we can increase the accuracy, but try to maintain this coverage, because we don't want like many correct answers that are discarded wrongly. But yeah, but right now all the methods we have to sacrifice the coverage here.
Thank you. And I actually I have a question about graph A. I was hoping you could clarify like on this same slide. I was hoping you could clarify uh like the point density and what that means.
Oh yeah, great question. So initially we have like the 15 human pre-designed agents. And here we query the RM to generate about like the 20 agents. And then among these 20 agents, we select like 15 agents that can perform relatively better. And then so we combine these 15 newly generated agents with 15 original agents and form a group of 30. So among these 30 agent groups, we like randomly sample, like randomly choose 15 agents among these 30 groups, these 30 agent groups, and then we calculate their average score and coverage. So that forms into this plot. I mean,
Uh
each point here refers to like each group types, and you'll see there are several groups that can perform like both better average score and better coverage. And we
Gotcha.
think
Okay.
this kind of like the agent groups, they are more diverse and more like high quality. Yeah.
Right, right. So it's just like it's like a 3D type of graph, and it's like a I see what you mean. Like
Yeah, yeah,
I see. Okay.
exactly.
Yeah, also I wanted to ask you, so I was trying to understand what diverse agents means, and I get that you're like prompting an LLM to generate, I guess, code for like more diverse agents, but I think maybe it would make more sense if you could give us an example of like something in the data set and then how Gemini generated diverse agents to answer that question. Like what does that actually look like?
Oh, great question. So first I can show you like what's our initial agent. The initial agent is like a simple, like some agent is just like a COT, like pure texture based chain of thought. And some agent we prompt them to use code, and some are single round, some are multi-term, and
Hmm.
I found like the LM generated agents, they will like force some strategies. Like first, in the first round, you always use code, and in the second term, you
Hmm.
always use test. And this kind of adaptive agents are what LM use. And also LM will like generate other agents, and these kind of agents um, are like in the first you always you just use code and browsing and also test, and then in the second you gather them together. Yeah. So
Do you
these
think
are
like,
different
oh,
strategies.
sorry.
Yeah.
Yeah, I see. So do you think like if the diverse like agent generation was even more sort of free, like you could like literally ask almost like asking Cursor like generate any sort of solution, anything to solve it, do you think that would lead to more success, or do you think constraining it to a set of sort of like paths or pre-designed agents is probably better?
Oh, great question. So, in our work, initially we just test the Tumix on our pre-designed agents, and then we prompt LLM to generate more. And based on our detection, LLM generated agents, some are very bad, some are good. So if we
Mhm.
can like have some filtering methods, like just to filter out some like the better agents, that will be, I think that will outperform the human design ones. Yeah.
Yeah, yeah. No, I think that makes sense. I also wanted to ask you, what do you think is like the practical takeaway here? Like, do you think that people like, do you think this should be for kind of difficult tasks, like for agents that are not successful, maybe you want to do like a bag of agents, like people should actually do that in practical cases, or do you think that this is more of like a result that should lead to like more research, or what do you think is the biggest sort of result, I guess?
Good question. So I share this slide again. I think this kind of technique, currently like the LM companies, they are directly using this. For example, you can see the Google's report. They say like when we use higher compute, it will like arise from like 26 to 32. So this higher compute means they are also doing this kind of like a parallel rollout.
Right,
Yeah,
right.
and also like ChatGPT, they are using parallel rollout.
Mhm.
And but the strategies to use parallel rollout, they are different. For example, they can just like sampling multiple times and select the most frequent answer, and that's
Mhm.
one strategy. And my strategy here is like you use different agent or strategies
Mhm. Mhm.
to be more diverse. And I found my method is can scale much better. Like for example, you can see the scaling curve here. When compared to other like baselines, my method can be better scale. So
Right.
I think one hint for I think one takeaway for our work is like first to extensively utilize the capabilities of like the tools and incorporating it to the LM is itself's reasoning capabilities. Um, there is one method that can be training free that we don't need to use like a reinforcement learning, that we just use kind of agent framework that can already give us many benefits. Another takeaway I think is like for this kind of like the full integrated test time scaling, um, purely like just using like the best of n, it's kind of like the you just scaling with multiple agents, with multiple rollouts, and then select the most frequent one. It's not as effective as like you just pre-design many different strategies and then do the test and scaling based on it. So so still like the takeaway is like the diversity is very important.
Mhm. Yeah, no, I think those are some awesome takeaways. So that's great. Cool. I think yeah, I think that's it for us then. Parth, any more questions?
No, thank you. Yeah. Thank you for the presentation, and I really appreciate how digestible you made it. Yeah, thank you. And thanks everyone for
Okay,
coming. I hope you enjoyed.
All right, cool. Bye, guys.
okay, bye bye.